Okay, we are going to start now.
Okay.
You remember the last class we talked about what? You still remember?
Yeah.
Yes, can you tell me?
Good
About
morning, Miss.
Good morning, how are you, Abdallah?
My name is Muhammad.
Muhammad, how are you? I cannot say, hey, Obeidili, I'm happy to see you. How are you?
Fine, Miss.
Okay. So last time in the lesson, the class, we talked about the sphere, the Earth sphere. Can you remember how many did we talk about? The Earth system.
4.
4. Very good. Excellent. Can you mention them?
Yes, geosphere, biosphere, hydrosphere, and atmosphere.
Excellent. Yes. We talked about the hydrosphere. We talked about the geosphere. We talked about atmosphere. And we talked about what again? The fourth one? Turkey, I want you to talk about
Hydrosphere.
hydrosphere. Very good.
Sorry.
So today we are going to look at the exploration 3, relating ocean circulation to the flow of matter and energy. You know, we want to see that in the ocean, not only water that is flowing, there are some other things that are flowing in the ocean, that are moving. When we are talking flowing, we talk about things that are moving in the ocean. Can you, before we go on, can you tell me some of the things that are moving in the ocean?
fish.
Fish, good.
Sea creatures.
Yes, very good.
Um, people throw garbage in the. People throw garbage in the.
Yes,
ocean.
excellent. If you see
They live
now, many people, they are throwing so many garbage into the ocean and disturbing the ecosystem of the ocean. Okay. So today we are going to look, there are some other things, not only solid, we also have gases, okay? We also have gases that are moving also in the ocean. Now you can see this, that is the ocean of the earth, and that is how it's moving. We have the current moving all the time. And also we have the 2 major currents. Can you tell me those 2 major currents that we have in the ocean? We have 2 major currents. We have the surface current, the one that you can see. Yes. Surface current, and we have the deep. You know, the one up and the one down. You know, the one that is down will be deep, and the one that okay, we continue, but just try to follow me, okay? So we can see the movement, the movement of the ocean current. And I was talking about the deep current. The deep current is the cold current. You know, the cold water, like the cold water, has more density than the warm current. Because warm current, the density is low and it can go up and it has high energy. So with the energy, it can move faster than the warm. I will take what
Miss Ola,
yes.
I can't hear you.
You can see the light here. If you see that light, you see that it's moving in a circular form. That's why we call it convection current in the ocean. When the water is warm, it will go up, and when it is cold, it will come down. And we have the cold current from the okay. So I will go on with that, that if you look at it, you will see that this is the reason why you have the currents in the ocean moving because of differences
عبد
in
مسعد يلا joined.
density. Okay, I've seen it. I've seen him. Okay, so and with that, when denser, like the experiment we did, and Abdallah also did it also for us the other time, you know, the cold current sinks and the warm current, they flow up. And when you see this, when denser material sinks, less dense material around it is pushed up. Convention also describes the transfer of energy due to the flow of matter. And not only in the water alone that we have the convection, we have also convection in gases, liquid, and solid that flow slowly. We have also that. In the Earth system, convection happens in the atmosphere, in the ocean, and other bodies of water, and in the rock deep inside the Earth. And that is talking about the lava, okay? A convection current forms when convection happens repeatedly or in a circle. And that's where you have this one. That's how it moves. Okay, the movement is a circle. Please don't unmute yourself. I want everybody to be muted now so that we can concentrate. And if you look at this now, this is the globe, this is the Earth. The blue things that you see there is the water, is the ocean. And you can see the movement, the current moving. I've shown you this picture before, but this is the continue, and is in form of what the convention current is in form of convention. That's the reason why you see it moving like that. Now, the warm surface current moves towards the pole. Why? Who can tell me why the warm current is moving towards the pole? Why?
Because it's being pushed by the cold air.
Yeah, because, yeah, push to, because it's moving from the equator to the pole. Why?
Because it's getting pushed to the pole.
It's getting pushed to the pole, yes. That's part of it, but how? Ahmed Laban,
Because of the cold air.
because of the cold area? Yeah.
The cold air.
Okay, because of the cold air, yes, very good. You are trying, that's good. What about Turkey? Turkey and Abdullah,
not
can I
air,
see your
not
face?
air, water, not air, water. The water.
Turkey, where's Turkey?
Here.
Yes, I want to see your face and Abdullah. Okay, can you tell me why it's moving? Obedili says something now. Yes, why is the warm surface current moving towards the pole? You know, it's moving, the warm current is moving from the equator to the pole because number one, the current is warm. Number two, it has a very high energy. You know, energy, transfer of energy is from warm area to the cold area. Okay, and if you look at the particles inside the warm object is always moving. The kinetic energy is very high compared to that of the cold current. And that's why you don't normally see the cold current on the surface. It's always at the deep down in the ocean. And it doesn't have so much energy. And if you look at it, you can see that that's the reason why to replace, let me show you this one again. You know, let's say that this is the equator. Look at it, the red one. As the water gets warm, it will go up to the equator, then the cold one will come down, get warm again, and go up again. So
yeah, because the cold water is pushing it.
yeah, the water is pushing it, and because of the temperature makes the water to have more energy. You know, when the water is warm, it has more energy, it becomes light,
Yeah.
and it can move faster. So that's the reason why can you say all the water, all the currents on the earth, that's how everything is moving. That's why we call it conventional current. Looking at this,
Miss,
yes,
I will go to the toilet.
okay, but don't be late, please.
Okay.
Okay, we will continue. Do you understand now how days is moving?
Yes.
Okay. Now, let's see what's happened in the ocean now. Okay, so you can see that the warm surface current moves towards the pole, carrying energy from the equatorial region. Then the deep current moves back to the equator, okay? So the cold will come to the equator, become warm, and go back to the pole again, become cold, come back to the equator. That's why it's in form of a circle. And warm surface, let me show you this picture. Okay. Now, can you see this picture? This is what happened, okay? You see the red one, the red arrow shows the warm,
Water.
yes, warm surface current. That's why it's always up, okay? And the deep current move towards the equator.
Good.
Can you see the arrow, how it is moving? So when it comes down again, the same thing will continue. The same process will continue. So A is what? Warm surface current moves towards the pole. As it's getting to the pole, can you see the water moving? The warm one moving. So when it gets to the pole, can you see what happened to it here? It's become cold, go down, and coming again to the equator, it becomes warm again and continue. That is what we call this convection current in the ocean, in form of a circle. It continue moving like that. Okay. Then can you see the deep current moves towards the equator? The same thing, it continues like that. Okay. So that one will take us to the next one. I know that you can understand what is called the convection current. This map is showing what is happening all over the globe. Now, about this convection current.
Miss, what is the pink?
Pardon?
What is the pink?
Big. Which one? The pink?
Pink.
It shows the warm. That is the warm current, okay? That's the area around the equator, okay?
Yeah, close to the equator, it's hot.
Yeah, close to the equator is very, very hot because it's very close to the sunlight. Okay, now, involve the sinking. Now, this is just the explanation of how the convection happens, the convection current. Number one thing is that the dense water, which is the cold water, will sink, okay? And the less dense, which is warm water, will come up. This process takes place all over Earth's ocean to form global circulation patterns. And that is what is happening all over the world in the ocean. These patterns include surface currents that carry warm, less dense water away from the equator. Like I explained before that, from this equator here, you have the warm current. It will come, because it's less dense, it will move to where that is what? That is cold area. And that's the reason why we have different climates. We have different weather, because when you have warm currents, you have different there are different climates at that particular time. And that's why the ocean, the Earth's ocean is very, very important to us, because it determines so much about our climate and the weather too, okay? So these patterns include surface currents that carry warm, less dense water away from the equator towards the pole. Water from the deep ocean near the equator rises to replace the water that is moving away on the surface. I've explained this one before, that as this the deep currents will come from here, come to the equator, get warm again, go back to the equator, get warm again, and so on and so forth. That's how it continues. Okay. Now we're going to look at the global ocean circulation. Okay. And if you can see that everything is in form of a circle. When you put all the ocean currents together on a map or a globe, you can see a pattern of water movements in the ocean. The model can be thought of as the main highway on which ocean water flows in all Earth's oceans. If you could follow a molecule of water in one possible path, you might find the molecule takes more than 1,000 years to return to its starting point. It's not something that is very, very fast. It takes a lot of time. And that's why in different parts of the world, you will have different weather here and there, climate, because of the what? Because of the circulation of the ocean currents. We have different ones like that, okay? Now, and that one will take us to the next one. Can you see?
Yes, the screen is freezing.
Yeah. That is, we show, can you see the movement? Okay.
No.
This is to show you how the ocean current moves. The red one is showing the warm current, and the blue one is showing the cold one. The warm one is going towards the pole, you can see them, and the cold current is coming from the pole to the equation current. Now we are going to look at this. Look at this picture.
This is the pattern.
Yeah. Can you see the pattern now? Now let's look at the A is standing
Yes.
for where? We have A, B, and C. Okay. That is near the pole. See A here is near the pole. You can see the ice caps there. Okay. And what happened in this near the poles? In cold areas near the poles, energy flows from the ocean into the atmosphere. The ocean water gets colder and more dense. This cooler, denser water sinks and then moves towards the equator along the ocean bottom. You know, the cold current doesn't move on the surface, doesn't move
Yes.
on the top. Yes?
There can be convection. There can be convection if the water is freezing.
No, if it is freezing, no. Actually, convection is likely to happen, is mostly likely to happen in liquid or semi-liquid, okay? So if it is frozen, no, there will not be any movement, okay? So you can see that the ocean water gets colder and it will come down, sinks and come to the equator. Now let's look at B part. This is what we call upwelling. Upwelling. In areas such as the Indian Ocean, at this spot where you have B, okay, you can see that along the west coast of South America, deep water comes up to the surface. You know, normally it's supposed to be down, but when we say something is upwelling, coming up, okay, coming up, we get up, coming up, okay, comes to the surface. This upwelling of deep water brings cold, nutrient-rich water to the surface. Then this is the C is near the equator. Can you see the C? It's near the equator. And near the equator, the surface ocean water absorbs solar energy because it's very near to the sunlight. So they easily get solar energy that make the water to be warm. And this warm water tends to flow towards the pole and replace the cold water that is sinking. If that one is not happening, let me tell you, some areas of the world nobody will be able to live there. And if these ocean currents are not moving, people that are living area the equator, they will be burned to death because it will be extremely hot. And also at the polar region, it will be extremely cold. And that's the reason why this current that we are talking about, we are studying, we are not just studying it for studying's sake, but just to let you know the effect of the current on climate, on the globe, on the earth, or the climate. You know, as even here in our place here in Qatar, you know, around December we have the winter. Okay, we are in the summer. Everywhere is hot now, and all those. It's because of the current that is keep on moving. And we are close to the equator. I don't mean that the currents are not moving. Let me tell you, we not have anything like winter, and it will be so unbearable for everyone. So the continuous movement of the ocean current is very, very important to the globe weather, to the weather of the earth. Okay. So, and that will take us today. I will give you time to ask me questions, but I want us to move on because of our time. Yes, I want somebody to explain this picture. Can somebody try to explain? Yes, what is happening here?
Lake storage.
You have what can you see there? You have lake storage. You have the ocean storage there, okay? And you have the evaporation.
Because they want to put fish inside.
Okay. So now you have the precipitation. Yes, Ahmed Laba, can you tell me some examples of precipitation that you know? What is precipitation? Yes, Ahmed Laban. Turkey?
Yes.
Yes, what are the examples of precipitation? Abdulaziz, how are you?
Fine.
Okay.
It is in the cloud and it falls and it just from the ground.
State. If you look at the energy compound, so where is the energy coming from? The energy from where? Okay, energy is transferred from the earth. So the ocean influence, like I told you before, on weather. Okay. And on the climate. Also, if you look at the equator too, the same thing happened. They have a lot of energy, and that's why we have the different climates all over the world and the weather.
That's better joined.
Oh, that's good. Brother, how are you? Good morning. Wow, I'm so happy to have a large something today. That's a good one. Okay. Now we quickly look at some cycling, some things that are moving in the ocean. We can see the warm current, the cold current. Okay. This picture are some of the things that you can see in the ocean. That's plankton. And the cycling, these are the, this is the source of the plants of the ocean. Let's say that all those plants that make photosynthesis in the ocean. Diatoms are one type of the plankton. So the matter, those things that are moving, ocean currents transport not only energy, but also matter in the earth system. Those things that the ocean current transports, that is that it moves, those things that the ocean current moves are the ocean water itself,
مثل
solid,
سبونج بوب.
solid as salt. You know, we talked about the salinity the other time. So the ocean also is moving the salt. We have the gases such as oxygen and carbon dioxide. I want to ask you a question. Where does the ocean get oxygen and carbon dioxide from?
From air.
Yes, but there are some things in the ocean that give the ocean the oxygen and the carbon dioxide.
I know.
Yes, tell me.
Sunlight.
Sunlight. How? Yes, sunlight will be true, but can you tell me how?
Because it's hot.
It's not. Okay, what about the plants? in
The plants get energy from the sunlight to move.
Okay, that's a very good one. The plants get energy from the sunlight to do what?
like to live يعني to survive and eat food cycle ما أدري شنو.
Yeah, to live. That's a good one, but how are they living with sunlight? How?
Because they
No,
are
yeah. mm,
Yes, tell me how.
I don't know.
Yeah, you are correct, but I want you to explain to me how you get your answer. You are very correct. The plants in the ocean, they get energy from the sunlight. Okay, so they use that energy to do what?
To live, to reproduce, to
Yeah, very good. To live, to reproduce, to make food. You remember your photosynthesis. Yeah. So plants in the ocean also, they make their own food, and the energy to do that, they get it from the sunlight. So, and that's the reason why you have, we have fish also living in the ocean. So how do they get oxygen to live? So they get the oxygen from the plants during the photosynthesis, and also the carbon dioxide. We take in oxygen. Animals they take in oxygen, and the plants take in oxygen, carbon dioxide. So the exchange is taking place. Then marine organisms such as plankton too. So some substances transported by ocean currents are harmful to the environment. I remember that Obedili told us that when I asked the question that what are those things that are moving in the ocean, he said something about the garbage, the rubbish. Okay, so all these ones also, they are very, very harmful to the environment. These are also transported by the ocean. So you can see this. Ocean water is served, the salt, oxygen and carbon dioxide, marine organisms, and some of these things are very harmful to the environment and very, very bad to the environment, especially the pollutants and the human waste. Some they poo and they put it inside the ocean. Some, when they wee inside the ocean. All these ones, they are very, very bad to the environment. Now, this is a picture of what is happening. Okay, we call this one carbon cycle. Carbon cycle. That is the carbon dioxide in the atmosphere. How do we get the carbon dioxide into the atmosphere? If you look at these small, small arrows, you will see one going up and one going down. Okay, the one going up is that we get it from here.
there is
Guys here? Yes, tell me. Let's look at when you burn fossil fuels, okay, carbon dioxide will go to the atmosphere. We get carbon dioxide from the fossil fuels, and also respiration. What do you mean by respiration? When you take in oxygen and you give out carbon dioxide. During this respiration also, you release carbon dioxide and it also goes to the atmosphere. Okay.
Someone joined.
Who joined?
Ibrahim.
Who's this?
Miss he wants out too.
Okay, let's continue. Okay, we want to look at where we get carbon dioxide from. Okay, also from volcanic activities. When there is volcano, also carbon dioxide is released into the atmosphere too. Then carbon in living and dead organisms also. So all these ones, from here we get carbon dioxide into the atmosphere. And also as carbon dioxide is going into the atmosphere, we are also using it, because if we are not using the carbon dioxide, the atmosphere will be full, too much carbon dioxide in the atmosphere, and it will be very, very harmful to everyone. So the plant is using it for its photosynthesis, okay? The plant is using the carbon dioxide. Also, all the organisms, the ocean organisms, they are using the carbon dioxide to do photosynthesis, okay? And also, they take in it and release it. Then they exchange the carbon, the organisms in the ocean, they are also releasing the carbon dioxide. Okay. Yes. Now, I want to ask you a question. If there is no plant in the ocean, what will happen?
What?
If there is no plant in the ocean, what will happen?
The fish will die.
The fish will die.
No, they cannot live.
They cannot
They will
live.
have
Why?
they will have a hard time.
Yeah, very good. But why? How?
Because I
Yes,
don't know.
you are
Because of
trying.
the carbon dioxide.
There will not be carbon.
If there's the plants, they are using carbon dioxide to make photosynthesis. But if there's no plants in the ocean,
The carbon dioxide will stay more because the plants consume it to use photosynthesis, and if they don't use it, there will be more left. Malek.
excellent, excellent. And also, you know what? The water, the ocean is about how many? Is about how many percentage?
97.
No,
Analysis.
that one is about the fresh water and the salt water.
70%.
75%. Okay, so can you see that most of the oxygen that we are getting from the earth, we are getting it from the water, most of the oxygen. So if the plants in the oceans and there are no plants in the ocean, then definitely, even we also will not be able to live on earth, because most of the oxygen are released from the water too. Okay, so and during the process of photosynthesis, you know, the plants, they take in carbon dioxide and they release oxygen. The same oxygen, the animals, the organisms in the ocean, they are using that. Okay. So now that will take you to the next slide, and that's where I'm going to end today's lesson. Then I will take your attendance. Okay. So this is like a revision of what you have done before. Okay, like combustion, the exchange of carbon dioxide, when you take in oxygen, that is respiration, and you give out carbon dioxide. Can you see the leaf? Okay, the sunlight is giving the energy, and the plants, they will take the carbon dioxide and water to give what? To produce. You have the oxygen. Yes. Tell me. Any question here? I want to take your questions now. Okay. So ocean water can absorb carbon dioxide, and carbon dioxide can be released from water into the atmosphere. So the ocean plays an important role in regulating the amount of carbon dioxide. So they regulate. If the ocean is not there, we have too much carbon dioxide in the atmosphere. Okay. So you have any question you want to ask me now?
I'm hungry.
Yes, ask me. Now let me know
أنا تعبان.
how many people are present today.
Me, I'm present.
Yes, I
I'm
have
present.
Ahmed Laban,
30.
Me محمد
Sophie,
الرازي.
And me. Me, miss.
Abdallah. Abdallah, I cannot see your
Malak.
face.
Yeah, the
Someone
camera
his
is not
name is
working.
Jeff.
I don't know why.
Okay,
Camera
Ablaziz, I
خربانة.
can see Ablaziz.
عزيز عباد.
Miss, I am here.
هاي بدي سوسن.
جيمر جيمر والله حركة فيديوهاتك بس
من؟
على الايباد.
Gamer.
Okay, I have only 1, 2, 3, 4,
Miss.
5. No, I think
Five
it's
what?
more than 5. 1, 2, 3, 4, 5.
Miss also عزيز علي ايه عبد العزيز علي ايه.
Miss,
Five.
كم في عبد العزيز بالله عليك؟
Somebody is trying to
60,000 واحد.
Miss 5 people.
فشلتنا عزوز.
6 people.
I think we are
بحب
6.
الضحك.
Who
انا
is the
الساعة
6th
كم؟ حد
person?
يعرف الساعة كم؟
coronavirus.
Who is the 6th person?
10:43.
Turkey.
Abdullah Saleh. I Saleh. سيف.
ليش ما يعرف يقرأ؟
على يعني من وين تألف؟
فضحتنا يا بدر.
اي والله يا
Okay.
بدر.
مخدوم.
Now, let's quickly look at this
كيف
one to finish.
مس.
Miss, we don't have time.
Yes,
زيرو minutes.
No, it's
Yeah.
0 minutes. صح.
11:43.
I know.
10:43.
Okay. Now, I'm going to end today's meeting here, okay? And I will post this into the Edmodo group and make sure that you do what? You do your homework. Very, very
Miss,
important.
Miss,
حد يعرف الساعة كم؟
Yes.
you know, only 4 more days and then we have vacation.
10 وش اسمه.
We have vacation.
10 vacation, Miss, vacation for 4 months.
My God.
How did you get that information? Just follow whatever is
سوي
given to
صرخة
you, okay?
ثمنيل.
So see you next class. Thank you. Bye.
يلا
تركي
peace out.
بنلعب انا وانتم محمد.